992 subarrays with k different integers. Let me first explain the problem, because this problem gonna be a little bit harder than the other sliding window problems. Yeah, because if you think directly, yeah, you're gonna find the subarrays with exactly k different integers. So for example, let's try to use this example. Yeah, so we have a nums like that. So we're gonna check the subarrays with 2 different integers. So yeah, like this kind of a subarray, we're gonna find 1 2 2 1 until 1 2 1 2. So in total there are 7. Yeah, if we use sliding window directly, we're gonna find a k different integers. We first find 1 2, and then we're gonna, for the right pointer, we're gonna go to this one 3, and then the right pointer will go to 2. Yeah, so 1 2 3, we find 3 results. Now for the left pointer, we shift by 1 4, and then we shift by 1 5. Yeah, as you can see, this is 4, this is 5, but that is not exactly the answer, because while, for example, while you are shifted this 2 to 1, you think 2 1 2 is a result, but in between 2 1 is also a possible result. Yeah, so this means it's gonna be really hard, yeah, if you solve it like this. So for example, from this 1 2 1 2, you're gonna find 3. Now you wanna shift the left pointer, yeah, until here you find 4. Maybe you shift the right pointer to the left until here you find 5. Yeah, and yeah, you shifted this one, you find 5, and the last one you're gonna find 6, but it's not the result. Yeah, but that's gonna be really difficult if you like, yeah, you shifted from the left to the right 1 2 3. Next, if you shift the right pointer, yeah, if you shift the left pointer 4, yeah, until here you find 4, until here you find 5. Yeah, it means in total you find 5. Yeah, maybe you shift the left and the right, but the programming is not like that. So we're gonna use reverse thinking to solve the problem. If we wanted to find the k different integers, so what about we find the at most? Yeah, what about we find at most k different integers minus, yeah, let me use this kind of at most, yeah, minus at most k minus 1. Yeah, if we can solve it like this, at most we can find k integers how many different ways? Yeah, and minus at most k minus 1 different integers, so that is exactly k integers. Yeah, so this means if you solving the problem hard, really hard directly, you're gonna use reverse thinking. You're gonna solve it in the easy way. So in mathematics, you're gonna solve it at most k and at most k minus 1. So this is gonna be the same while you are solving at most k or at most k minus 1, because for the mathematics it is the same formula. But is this gonna be easy at most k? Yes, because the sliding window is designed for solving at most k different integer problems. Yeah, so for this example, from the left pointer, at most from here we're gonna count 1, and then it goes to 2, so we're gonna count 2, and then it goes to 1, we're gonna count 3, 1 plus 2 plus 3 until this 2 we plus 5. Yeah, so this is why it is so easy while you are solving at most. Yeah, so while you are going to this 3, it is not possible. Yeah, because there are 3 integers, you're gonna shift to the left pointer, it is still 3, you're gonna shift to the left pointer, it is still 3. Until here, it means it is 2 integers, so you're gonna start counting, and then you shift to the left pointer, go to this position. Yeah, so you're gonna still count it, yeah, until you go out of the boundary. So in this way, it's gonna be really easy to solve at most k different integers. Yeah, if it is so easy, so we're gonna solve it like this way. Yeah, so let me first write the at most function. So for the sliding template, it's gonna be the same. So the L pointer with the result 0 and 0, I'm gonna prepare n should be the length of the nums, and I also need a counter. Let me use a C. So the C will be the counter. Now we're gonna enumerate from the right side for array in enumerate the nums. So our counter would be updated by 1. So C with V should plus equal to 1. So we're gonna check while length of the C is more than K. It means out of the boundary. So L should plus equal to 1. But before that, we should update the counter. So C nums L should minus equal to 1. If C nums L equal to 0, so we're gonna pop it out because we will not count with values of 0. So nums L will be popped out. Yeah. So if it goes out of the while loop, it means we've already found the answer. Even we didn't go into the while loop, we still found the answer. So the answer will be result plus R minus L plus 1. I think this kind of function is really easy. Yeah, because this is at most. So what we're gonna return? We're gonna return this result. Yeah. Now we will put all this code inside a function. So what is that function? So it is called at most. Yeah. So inside I'm gonna still have a K because it doesn't matter. Yeah. Now this is our function. So what we're gonna return? We just need to return at most. Yeah, let me copy the code from here. Yeah, we just return this line of code. Yeah, so it's gonna be at most K minus at most K minus 1. Yeah, as you can see, this is a really hard problem if you solve it directly to calculate K different integers. Yeah, but if you can use another way, you're gonna calculate at most K different integers minus at most K minus 1. So this gonna be exactly K different integers. So this gonna be really easy. Yeah. Now let me submit it and let's check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. And the time complexity is O(n) because we just use 2 functions of the sliding window, and each of the sliding window it will be just